This is a quiz review for solving and graphing radicals. So I've already did a separate video on solving radicals and a separate video on graphing radicals if you need more in-depth learning on the concept. I'm going to go kind of fast on this. So for example 1 through 3, it's asking me to solve radical equations, and I need to make sure that I check for my extraneous solutions. So what I'm going to do with this first one is I'm going to take that rational exponent of 1/2, and I'm going to raise it to the power of 2. And the reason I'm doing that is because if you recall, rewriting a rational exponent is, in this case, the top dog goes in the house, and then the denominator is your index. The index of 2 means square root. So in order to get rid of a square root, as in like on this side, you raise it to the power of 2. So that's why I raised both sides to the power of 2. And you also learned that 2/1 is really the fraction, and diagonally, if the numbers look the same, you can get rid of it. So what's left over is going to be m plus 8. And then on this side, the purpose of raising it to the second power was to get rid of the radical. So now I have the radicand to bring down. At this point, I want to combine like terms, so I'm going to subtract m on this side, and what I do to one side, I do to the other, and I'm going to subtract 5 on this side. When I do that, I get rid of the variables on the left-hand side, and I get rid of the constants on the right-hand side. So I'm left with 3 is equal to m, or I can rewrite it with the variable on the left-hand side of the equal sign. But before I say that that's my answer, what I want to do is check for extraneous solutions. So I'm going to go back to my original problem, and I'm going to substitute in that m. So that would be 3 plus 8. And again, you may see it better as the square root, because all of that raised to the 1/2 power means square root. And then I want to take the opposite side, and I also want to substitute in for that m, the 3, and then it says plus 5. So if this 3 works, that means that both sides will be the same. So 3 plus 8 underneath the radical is 11. And on this side, if I simplify, 2 times 3 is 6, 6 plus 5 is 11. So therefore, I know that m can actually be 3. For example 2, oops, let me get that out the way. For example 2, it's similar, except this time I have a cube root. So what I want to do is I want to take things apart. I want to get rid of the constant first. The constant, in this case, is positive 2, so I'm going to subtract 2 on both sides. And when I do that, that goes away, and I'm just going to bring down my negative 6 times cube root of the quantity 4n minus 8. Set that equal to negative 48 once I combine those two terms. And now what I want to do is divide both sides by this negative 6 so that I can get the radical by itself. So now I have the cube root of the quantity of 4n minus 8 set equal to, and this is going to be a positive 8 now. That's negative 48 divided by negative 6. Now, to get rid of this cube, I need to cube it. I'm sorry, cube root. To get rid of the cube root, I need to cube it. So what I do to one side, I do to the other, and that's going to get rid of the cube root, and I'm left with 4n minus 8 is equal to 8, excuse me, 8 cubed is really 8 times 8 times another 8. And let me find my calculator here. Oh, it's 512. Now what I want to do is get n by itself, so I'm going to add 8 on both sides. And I end up with 4n is equal to 520. And then I want to divide 4 on both sides so that n can be by itself. And when I do that, n becomes 130. So again, when I'm solving, I always want to check for extraneous solutions. So I'm going to go to my original problem, which is this negative 6 times the cube root of 4. And instead of n, I'm going to replace it with the 130 that I just solved for. Subtract 8. All of that's under the radical. and I'm going to add 2. That's not under the radical. And if this simplifies correctly and I can use this answer, then it should equal negative 46. So here I have negative 6, the cube root of, and then I'm going to multiply 4 times 130, which is 520. Subtract 8 from that. Take that answer, add it to 2, and let's see what happens. So in the calculator on the side, I'm not showing you what I'm doing, but this is actually going to be, that cube root answer is going to become 8. And then I'm going to add 2. And I can see that it is going to actually be negative 46. So if it is balanced on both sides of the equation, like I said, then I know that this is not an extraneous solution. This is my actual answer. And then the last one for solving, it looks like this problem. All right, so this time I have a radical on the left-hand side, and I have on the right-hand side a constant and a radical. You can you can raise it to the second power, however, it's going to operate differently. So on this side, all of the terms are under the radical, so I can automatically get rid of the radical. On this side, however, I cannot get rid of this radical because everything is not under the radical. So what I'm going to have to do on that side is multiply binomials. So I'm going to bring down my 2x plus 2, which is my radicand that's left over after I got rid of the radical. And on this side, I'm going to multiply 3, the quantity of 3 plus the root x, or square root of x, times another quantity of 3 plus square root of x. When I simplify this, I end up with that same 2x plus 2. But this time I'm going to go ahead and distribute. So 3 times 3 is 9. 3 times radical x, or root x, is going to be positive 3 root x. And then I'm going to do that again. I have another root x times 3, which is positive 3 times root x. And I've told you before, a radical times itself is simply the radicand. So in this case, root x times root x is x. Now I'm going to continue to simplify by combining like terms here. So that's going to be 2x plus 2 is equal to 9 plus 6 root x plus x. And now what I want to do is I want to combine my constants and I want to combine my x's. So what I'm going to do is subtract x on both sides. And I'm also going to subtract 9 on both sides. That way I can just leave that 6 root x on the side by itself. So I'm left with x minus 7 is equal to 6 root x. And typically what I would do I would try to divide both sides by 6, but in this instance, that's not going to work, because if you divided this side by 6, this is what it's going to look like. We don't want that, right? So now what I'm going to do, since the 6 is next to the root, I can actually raise this to the power of 2. And I can also raise the other side to the power of 2. And I'm going to continue simplifying. And in doing so, this is going to end up being the quantity of x minus 7 times another quantity of x minus 7 is set equal to, now this 6 is raised to the second power, so that's 36. And then this is really root x times another root x. So again, it's just a radicand, which is x. So this is what I'm saying. It's times itself. All right, on the left-hand side, I distribute and I end up with x squared, negative 7x, another negative 7x, and then negative 7 times negative 7 is positive 49, set equal to 36x. I'm going to combine my like terms here, and I end up with x squared minus 14x plus 49 equals 36x. And then I want to combine my x's, so I'm going to subtract 36x, subtract 36x, And that will leave me with 0 on this side and x squared minus 50x plus 49. So at this point, I should see that I can actually factor this. So let's scroll over here and rewrite that. So x squared minus 50x plus 49 equals 0. That means I'm solving. So I already know my first term of each parentheses or binomial is going to be x times x because that's x squared. And then for 49, I'm looking for two factors that will not only multiply to give me 49, but they would also add to give me 50. So we know it's not 7 and 7. It's literally the number itself, 49 and 1, except I need a negative 50. So both signs have to be negative. So what I just came up with, I'm going to go ahead and put that inside of the parentheses. And I will set each one of these factors equal to 0. And what does x have to be to make that true? In this case, x would have to be positive 49. And in this case, to make that true, x would have to be 1. You should understand how to do this by now, but if not, set each factor equal to 0 and solve for x. Now what you want to do is check for your extraneous solutions. And that's me going back to my original problems. So my original problem said I had the square root of 2 times 49 plus 2. And then I set that equal to 3 plus square root of that same 49. So I'm going to have to do this twice, checking for both 49 and for number 1, or for 1. On the one hand, under this root, 2 times 49 is 98, and then 98 plus 2 is 100. On this side, I have 3 plus, well, root of 49 is 7, so 3 plus 7 is 10, and the square root of 100 is 10, so therefore this one works. 49 works. Let's try to do the same thing using 1. So I have the square root of 2 times 1 plus 2 is set equal to 3, scoot over some more, times, 3 plus square root of 1. And this time, if I, under the radical, I have 2 times 1, which is 2. 2 plus 2 is 4. And then on this side, I have 3 plus the square root of 1 is 1. So 3 plus 1 is positive 4. And if I take the square root of 4, I have 2 on one side, and then I have 4 on the other. So clearly, they're not equal. So therefore, I cannot use 1. That's my extraneous solution. So extraneous solution is the one that cannot be used. And you determine that by going back to check your work. And now, for example, 4 and 5, I will be talking about graphing, identifying key characteristics, as well as doing transformations. So this is the problem that I'm given, the function. So the function is shown here. And again, I have a video on graphing radicals, both square root and cube roots. This video is only going to talk about square roots, so you might need to go back and refresh your memory on cube roots. So for this one, for the vertex, what I want to do is locate my h and my k, because that's going to be my x and my y values, also my h and k. So this is going to be, and then you also have to recall that the x value, the one that's next to the x, you're going to change the sign. So that's really -7. And the one that's your k value or your y value, that is going to stay the same. So that is simply 3, a positive 3. You don't have to change the sign. All right. When I have a square root, I typically like to use these numbers as those numbers shown in my table, because if I take the square root of all of these y values, then the other way around. If I take the square root of my x values, then what's shown for my y is the output. And so if you were to actually look at your parent function, my parent function, let's say, is y is equal to the square root of x. If I wanted an output of 3, I would have to ask myself, what do I put in the place of x? So I would have to put 9. So that's the way that I typically try to teach it. So I start off with that table, and on this side, it should be easy as 0, 1, 2, 3. What I'm going to do is I'm going to use my transformation information so that I can create my new table, and my new table is what the points I'm actually plotting on my graph. So if I look at my X values, they're anything that's under the radical. So I said that you always change the sign of whatever that is. So it's saying +7 here, but it's really a -7 because it's X. Let's see, sorry. Under the radical is really X minus H. So I need to figure out what H is to make that become positive. So in this case, that would have been a -7, and that would have changed it to a positive sign. Make sense? All right, so -7 all the way down for my X values. And my Y values are going to be anything that's outside of the radical. So that's going to be what's associated with my Y values. So since this -2 is in front of my radical, I'm going to put it in front of the number that's in my table for every one. And what's happening is in my function, -2 is being multiplied times that radical. So -2 here is also going to multiply times this number. And then after the radical, you see a +3. So in my Y, and that's still associated with Y. So in my Y column, after my number that's in the table, I'm just going to write that same +3 all the way down. So my new table is going to allow me to simplify that, and that's going to give me the information I need to plot. So 0 minus 7 is -3, 1 minus 7 is -6, 4 minus 7 is -3, and 9 minus 7 is +2. On the right-hand side, if I multiply -2 times 0, that's 0 plus 3, it's going to give me a +3. -2 times 1 is -2 plus 3, which is +1. -2 times 2 is -4 plus 3, which is -1. And -2 times 3 is -6 plus 3, which is -3. So these are my new coordinates that I'm going to plot on the graph, on the coordinate plane. Also, if I am doing this correctly, this is going to be my vertex or my endpoint, depending on what you want to call it, the very first one. So if I go back to where I started, that is correct. Another thing that you can do is you can go to your calculator. So let me go ahead and pull that up because I did pre-type it in. And if you go to your Y equals and type in your function and you wanted to make sure that your table was correct, just go to second graph. And I said for -7, it was going to be a +3. So I'm going to go back and forth so you can see the comparison under the table here. And I said for -6, it was going to be 1. Let's see right here. And then -3 and +2. Let's see what's going on there. -3 is -1, and then +2 is -3. Also, if I want to see what the graph looks like so that I can make sure I'm plotting it correctly, I just hit graph, and I see that it's going towards quadrant 4. Another way that I can look at this is my original problem tells me that my X value right here is positive. So my coordinates will look like this. X goes first. X is positive. And then my Y is whatever is directly after my equal sign. In this case, it said it's negative. So my Y is negative. And in that other video, it talked about how the coordinates were listed by sign. So I know that if I went over to the fourth quadrant, this is going to be X is positive and then Y. So my graph is going to be going towards this quadrant. So let's go ahead and plot those points. I have -7, +3. Let me see here. -6, +1, -3, -1. +2, and -3. And my endpoint is this -7, 3. So I know it's going towards quadrant 4. And at the end of it, it's going to have an arrow. That arrow is going towards, on my x-axis, on my x-axis, positive infinity. And on my y-axis, negative infinity. That's going to be important in a minute. So let's go back over and start identifying what we can over here. For my domain is asking me on my graph, what are all of the x values that I can include on this graph, starting from -7? Well, I'm going to the right. So all of these x values can be included. So the way that I would write that is -7 all the way to positive infinity. So that's what I'm going to write. And I'm also including -7, so it's going to be in a bracket. Positive infinity is not included because it goes on forever, so that's what it's going to look like. My range starts from it's up and down, and it always starts from the bottom. So this graph from the bottom, really, if I straighten it out, it will go all the way from the bottom to this point here. And what point is that? That is 3. And I know that already from my vertex or my endpoint, whatever you want to call it. So this one would be starting off with negative infinity. Oops, I forgot to write range on here. So let me just write a space for that. So range would be negative infinity. And then it will stop at 3. 3 is included. So I'm going to use a bracket. If I'm doing this correctly, I will see my vertex information in my domain and in my range. Okay. My end behavior is asking me what's happening to the graph as x is going towards positive infinity. The graph itself. So as x is going towards positive infinity, if I straighten this graph out, up and down, which direction is it going? It's going towards negative infinity. So that's what the end behavior will be for y. Another way of saying y is f of x, negative infinity. Now, that's good enough for me, but some people actually want you to tell what's going the other way. Well, since I never go to negative infinity on this side, I have a stopping point. That stopping point is the actual vertex. So that's what's going to go in the next blanks. For x, the vertex was -7. For y, it's +3. Your increase or decrease intervals is just asking you what direction is the graph actually going. So you always go to the starting point. You're reading from left to right. If you took your finger or your pencil, what are you doing? Are you increasing or decreasing? You're decreasing, right? And you're decreasing on an interval. That interval is going only on your x values. So it's going to be the same as your domain because it's x values. So decreasing, and it's going to be from -7 to positive infinity. And you might say, why positive infinity when it's going down? Because again, we're talking x values. X values go this way. Yes, it will eventually go down, but that's a y value. So make sure you understand the difference. If I am referring to the positive interval and the negative interval, positive interval is any part of the graph that is above the x-axis. So wherever your x-intercept is, that's going to be your changing point. So -7. And then here it's hard to see what your x-intercept is. So you could either go to the calculator and figure it out by going to second trace. Let me just show you. So you can go to second trace and then go to number 2, enter. It's going to ask you to left bound. So left bound of what you're trying to find. So if I'm trying to find my x-intercept, this is left bound for this particular graph. So anywhere above it, I hit enter. And then it's going to ask for right bound. So I go below it. So anywhere below it, and I'm using my left and right buttons. I hit enter and hit enter one more time, and it tells me when y is 0, x is negative 4.75. So that's one way that you can do it. Let's go ahead and write that down. That's my x-intercept. So negative 4.75, and that's when y is 0. And the other way you can do it is actually do the math. So let's do that. If we know that our original problem was this f of x is equal to negative 2 times the radical times root x plus 7, x plus 7, and then a plus 3 over here. So now for an x-intercept, we know that y has to be 0. Another way of saying y is f of x. So if that's 0, this is negative 2. This is root x plus 7 plus 3. Then you want to do what you just did with solving. You want to subtract 3 on both sides. You're left with negative 3 is equal to negative 2 times root x plus 7. And now I want to divide both sides by negative 2. That's going to result in 3 over 2 is equal to root or radical quantity of x plus 7. And to get rid of that radical, I have to raise it to the power of 2, and then I would have to do the same thing on the opposite side. And that will leave me with 9 over 4. 3 squared is 9, 2 squared is 4. And then this side is x plus 7. And now I'm going to subtract 7 on both sides. And when I do that, x is going to end up being, like I said, you can do the butterfly method if you wanted to, because this is really 7 over 1, if you wanted to. So that would be x is equal to 9 minus 28 all over 4. And once I simplify that down, it is going to give me that fraction, the answer of negative 4.75. So that's one way of doing it. And let's go back over here. The reason I did that is, again, for your positive interval, it's telling me that anything above the x-axis is going to be included. So negative 7 is my starting point. And then I said that it's going to change at my x-intercept. So negative 4.75, and I'm going to use a parentheses here because it's going through. It's not just stopping there. And then here for my negative interval, I start off with that same negative 4.75, but this time I can go on forever to positive infinity because it is going to the right. And to the right on the x-axis is positive infinity. All right, and then finally your y-intercept. It's simply taking the same problem here, but this time you want to replace the x with a 0, because that's what happens with the y-intercept. So f of x would be equal to 2 times, now this time the x is 0, plus 7, plus 3, and now I want to solve for this. And when I do that, that's going to be negative 2 times root 7 plus 3. And if I were to put this in a calculator, it's going to give me negative 2.29. So let me just show you here. Yeah. So if I go to the calculator second, quit, and I typed in negative 2 root 7, arrow over so that I'm not including the plus 3 underneath, it tells me negative 2.29 or negative 2.3 if you rounded it. Okay. Oh, one more thing. Sorry. This is the last one. So now if I am given a description of a transformation, and I'm asked to write a function, the first thing you want to do is you want to write down the actual parent function. So y equals square root of x, or f of x equals this. But you want to leave some space because something can go before, under the radical, and after. It just depends on what the description says. So here it says vertical stretch by a factor of 2. So this is the same problem, that the same function. I'm just showing you what it would look like with words. Vertical reflection over x-axis. So that's negative. Had this said horizontal and y, then the negative would have gone under the radical. So make sure you are very specific when you are writing it, and when someone else writes it, that you know that it could be either in front after the equal sign or in front of the x, depending on if it says vertical or horizontal. Everything that's outside is vertical because it's associated with this y equals that. Everything that's inside is associated with x, so that means x is on the coordinate plane, goes left and right, so that means it's horizontal. So I've taken care of those two. Horizontal shift left 7 units. Again, it's going to be the opposite sign, so it's really +7. And then vertical shift up 3 units. So I do not change the sign of K. This is going to be plus or minus A times the quantity. And like I said, it's all explained in the other video. X minus H, the graphing radicals videos. And then this is K. All right. So sorry that it was so long. Thumbs up, subscribe. Have an awesome day.